In class example 1.35, we're given the graph of an absolute value function defined as f of x equals the absolute value of 2x plus 6 minus 12. We're then asked to sketch the graph of a new function g of x, which is defined as f of 3x. The big idea of this question, of course, is identifying which parameter is represented by the 3 and what the effect will be on the graph. We've talked earlier about how a coefficient appearing in front of the f would be an a value and a coefficient with the x would be a b value. So this is a b value. We know that the horizontal stretch factor is the reciprocal of that b value. So here we are expecting a horizontal stretch by a factor of 1/3. We represent this in the mapping rule by writing that xy becomes 1/3 of x and y, showing that each x coordinate is multiplied by 1/3. Let's go ahead and label the points on the graph and apply this transformation. When sketching a transformed graph, or when verifying the sketch of a transformed graph, I suggest you always start by looking at the invariant points. Here, because we've stretched horizontally, we should see invariant points on the y-axis. And sure enough, the intercept at 0 and -5 is our only invariant point. All other points should have shifted closer to the y-axis. Next, we're asked to determine an equation for g of x in terms of x. This means we'll have to make a replacement into the equation absolute value 2x plus 6 minus 12. Now, what do we use? Do we use the 3x or do we use the 1/3 x? Well, remember that the mapping rule tells us the truth about what really happened. So if we describe this in words, we'd say a horizontal stretch factor of 1/3. And a replacement should always be the opposite of that. So in this case, the reciprocal. So here, we will replace the instance of x with 3x. Now we can simplify this. The first step is probably the most obvious simplification and would generally be enough. However, we could take this a little bit further by factoring out the 6. And because that 6 is positive, the absolute value of that factor will remain 6. So we can write it out front like this. This added step is not necessary, but is equivalent. As always, you're encouraged to verify your answer using your graphing calculator.